AI that can do things in the virtual world. The very same technology applies to robotics. It just has to work on a on both it's harder because it involves more channels that have to move at the same time. It's not just text to text. It's not just translation or generate a sequence of proteins. It's actually move 15, 20, 1,000 muscles at the same time. Mistakes are expensive in the real world. Time is slow. Real time is slow. You can't accelerate the real world. And there's energy limitations. So the real world is difficult, but the same techniques work. And I can see behind the scenes the amount of effort to scale those techniques that worked well for virtual intelligence and make them work in the physical intelligence. The same techniques work. We just need to pump in more compute. And this is part of why you're seeing all this buildup of infrastructure, of computers and energy to support that. But it's clear to me all the curves show that this will be solved in the 2030s, early 2030s. And when that happens, all bets are off.
Welcome to the Lab to Market Leadership Podcast. Too many advanced science and engineering companies fail to deliver their innovations from the lab to the market. We're on a mission to change that. My name is Chris Reichhelm, and I'm the founder and CEO of Deep Tech Leaders. Each week, we speak with some of the world's leading entrepreneurs, investors, corporates, and policymakers about what it takes to succeed on the lab to market journey. Join us. Lab to market journeys start in a lab, obviously. And they're generally started by students, by PhDs, by postdocs, by researchers in seek of inspiration and, potentially thinking about starting their own lab to market journey, innovating their own platform, maybe building their own company, maybe not. And so my question this week is really around whether those in charge of the labs, those who are hosting this different group of research talent, are they able to create the kind of conditions where some of these breakthrough innovations are increasingly likely to happen? That's the question for this week. And it's kind of a leading question because I kind of already know the answer. And my guest this week is an example, is a great representation that it is possible. It's possible and it's likely. I am delighted to be joined this week by Professor Hod Lipson. Hod is one of the most distinct figures in modern robotics research alive today. He directs the Creative Machines Lab at Columbia University. And he is the James and Sally Scapper Professor of Innovation in Mechanical Engineering. His research spans everything from evolutionary robotics, self-aware and self-replicating machines, digital manufacturing, and AI for science. He has over 350 publications, over 50,000 citations. He has co-founded 4 companies, and a number of different companies have emerged from his labs, like Empire Robotics, or students from his labs have gone on to form some really great companies. Formlabs is an example. Just 1 month ago, the Financial Times even had a whole spread on Creative Machine Labs where they reference just the topic we're going to talk about today. I'm delighted to be joined by Professor Lipson. Let's get into it. Hod Lipson, thank you so much for joining me.
Pleasure to be here.
I want to start out with a quote. I just referenced in my introduction, I referenced the FT article from, I think, the 18th of April. And I just want to reference this passage in the article. The young roboticist took seat in a dim corner of the room. They spoke with reverence about the lab's director, a Columbia professor of mechanical engineering called Hod Lipson. Hod rhymes with God. He is the reason they are all here. Lipson makes robots conscious. Lipson's students make robots dance. Everything starts from Hod but it comes through me, Zhang said, Zhang being one of your students. That's a remarkable introduction.
Wow, no, this is I only read this couple of weeks ago, and quite I was surprised to see what it looks like from somebody else's eyes. Sometimes
Yeah.
you don't see things that are there. It's funny. I told him when I met this reporter, I said, "My name is Hod. It rhymes with Cape Cod." Okay, and I remember saying that because people I don't know how to pronounce it. I also want to make people comfortable. You don't have to call me Professor Lipson or something like that.
Yeah, yeah, yeah.
And it was interesting. That's where he took it. But I can see the origin of that statement. But yes, it is funny sometimes to see how people see things from a different point of view. That's quite
Yeah.
fascinating.
Now, I understand from the little bit of research that I've done that actually upon leaving university, your first choice, your initial step was not to go into research or to do your PhD, but you actually started a startup. Is that right?
Right,
You were
exactly.
involved in a startup.
Yeah, I founded a startup. That was my first company. It was a bit too early. It was a GPS tracking a startup. We wanted to. Is a friend of mine that from college, and we reconnected a couple of years later, and then we said, there's this thing, a GPS tracking. Let's do something with it. And back that was '94. So back in '94, most people don't know GPS was very, very low resolution. It was about 100 meters, and you couldn't do much. But we said, hey, we can track. This is for insurance companies. We can see how containers are moving across the country, and if they're going to make it on time or not, and
Mm.
if they're going off course. So this 100 meters is fine for that. It's a big business model. We developed a technology, it worked, and then we realized the hard thing is not developing the technology; it's actually getting it to market. It's getting somebody to pay for it. That is the hardest thing. The technology is the easy part. That was my first lesson, and my conclusion from that, after doing that for a couple of years, I said, you know what? I'm done with this. I enjoy the technology more than the chasing the money.
Yeah.
Let me go into university and do just the technology. Little did I know that university is still all you do is chase money and you chase idea and you try to get things into market. But at the time, it seemed like a choice. But I think the reality is it never ends. It's always mixed. If you want to have impact, you got to do everything end to end.
That's right. You Was it always mechanical engineering, and was it kind of always heading in the direction of robotics, or did that shift over time?
No, that shifted. It was. I was really always interested in intelligence,
Mm.
and in this dream of making it, I did this maybe this hubris of trying to make a something as clever, as sophisticated as a human, and it has a robotics angle, it has an AI angle. For me, for in the beginning, was a creativity angle. So it has all these pieces in it.
Yeah.
But mechanical engineering is one aspect. Probably, to be frank, mechanical engineering was the easiest way to get into this quest of making recreating life, and it's sort of the body, and that's how it started for me.
And so that was the starting point for you. People starting today, would you say how many roboticists see it the same way?
I
Are
you
more
know
likely these days to see it as AI first?
um, it depends. I well again, this is perhaps where I differ from many people. I think the AI part is basically solved. And it's taking care of itself at this point. It's moving forward. There's many issues to solve, but
Mhm.
the path is known. When it comes to the body, we're decades behind, and there's a lot further to go, and therefore there's a lot more for innovation at the bottom. When the technology is mature, it's very hard to compete. It's hard to get started. You have to join something that already exists. The bar is high, but robotics, the bar is low. And if you're gonna have start something, it's better to start there.
That's very interesting you say that. Um, I want to come into the whys of all of that in a minute, but let's set this up a little bit. In you and I have gotten to know one another a little bit over the last few months, and obviously in some of the recent research that we've done. If I think about your lab and the environment that you've created or you appear to have created, it's very different from a lot of other academics or principal investigators that we've come across. The kind of traditional story or narrative, if you will, is I was in this lab, I created this technology, I spun this out, I did this, and so on. I built this team, and we eventually raised capital. With you, it almost feels like the lab itself is the real focus, is the real engine of everything. And is that the case? Is it about the lab itself? And then, the other stuff is all benefit, or the other stuff is secondary?
It's hard. It's interesting to see somebody else's perspective. So sometimes when you're inside, you're boiled into it. You don't see how it's evolved. But I think there is a passion in the lab about doing something bigger, and so some of it comes from it's reflected in the name. I think I notice a lot of labs are called in a very innovative way. They're just called, Bob's Lab. Okay, it's usually the last name of the super, I think, dull, and it just says if you can't even think of a name for your lab, I mean, come on, how creative can you be? All right, this is to me always the number one thing. So I really believe in setting a sort of some people call it a transformative purpose for the lab. Okay, what are you going for? And this is when we the lab in its current incarnation is called the Creative Machines Lab, and that's part of our mission. I want to make a machine that is creative. It's almost an oxymoron, at least for most of the last 2 decades. That was an oxymoron to think of a machine being creative. I mean, there's nothing can be more opposite. But that is our purpose, is to create a creative machine, and that gives a purpose to the lab, and then the lab has it. It's almost as if it's its own entity. It's almost like a firm. It's almost like one of these big research labs that have a transformative purpose on their flag to organize the world's information or whatever it might be, and that I think gives people a goalpost. It gives them energy. It gives them a meaning, and then good things happen. I think once you give people that power, good things happen. And a lot of people are talking about what's the future of work, and we want to get into that later. But increasingly, people are coming back to this idea that it all starts with a purpose. And once you have a purpose, the rest falls into place. But if you don't have a purpose, you don't know where you're going, just want a 9-to-5 job, it's very hard to navigate. So I think that's inadvertently, that's what I've created by naming the lab, by thinking about having a passion towards the impossible. But I can't say I planned it. It's not like I sat there and, oh, let me see how I'm going to create a lab that spins off things. No, it's just I felt it.
It just kind of happened that way.
Yeah.
Is there how do you, that kind of organized chaos? It sounds like, a little bit like organized chaos.
It is.
And you're providing this North Star. We're going to create creative machines. What are creative machines? And you talk about the oxymoronic kind of relationship there. And that's, and that's quite cool and deliberate. How do you resolve that against the need for, to satisfy different stakeholders in your world? You've got, grant funding, you've got the university, you've got all these different pressures that you might be feeling in a person of your position.
I think, when I started my career, people told me, focus. You got to focus on one thing and be an expert in that, and that's how you get tenure. And I did exactly the opposite. I said, okay, it actually sounds to me a very risky strategy, okay? Because if you put all your eggs in one basket, what if you're not the world expert? What if the world experts doesn't, you don't get along with the existing experts, and it sounds to me so risky. I'm going to actually do a lot of different things, and I'm going to see what sticks. And this has always been my approach. Also, it's not just a political thing. It's also you just don't know what's going to work. There might be some problems that seems to be easy, but it's going to be hard. There's going to be some hard problems that actually turn out to be easy. So I don't have this insight to say, okay, I'm gonna think about this a lot. I'm not gonna choose the thing to work on. I'm gonna crack it.
Yeah.
I'm just gonna try out lots of different things, and I'm gonna see what happens. And it's easier to attract funding that way because you have a broader net. It's easier to attract students because you cater to a lot of tastes, and students come in wanting to do different things. I find it's actually easier to collaborate because you could do so many things that there's always something in your toolbox that's useful for somebody else. So it ended up being a much better strategy to be a generalist. And it's also, frankly, a much more satisfying journey because, I mean, if you would see the range of conferences that I go to, I mean, one day it's about driverless cars, the next day it's about food. I mean, and it's just a more interesting life. And finally, I've seen so many colleagues who, spend a career, let's say, developing, putting all their expertise in one area to be victims of their own success. They became so successful that they went into industry. Industry took it over. Driverless cars is a great example. And the moment industry takes it over, there's nothing for you to do in academia anymore. Industry moves so much faster and puts so many more resources into it. And if they don't have anything else, their career is over. So I think having that diversity is also mitigate some of those risks. So I think any way you look at it, it's a good thing to do, but you have to have that mindset that is opposite of what academia cherishes, which is focus, focus, focus.
Then where do you draw the line for your lab? And your lab has had a really good deal of success. In terms of its output, in terms of the companies that are emerging from it, in terms of the, reputationally. So if it's not about that focus, 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 then what is it about? It's got to be about something else.
No, it's
then
all
where
about
is the
impact.
bar for you?
It's all about impact.
Mm.
So you got to do something that's going to have impact that people care about, and it could be long term, but it's got to be something that's going to affect the world in some positive way in the future. And you can measure thankfully, there are now so many ways to measure impact. So it's not some hypothetical thing. You can measure clicks, you can measure citations, you can measure publications, you can measure funding, you can measure where do your students end up going. I mean, there are numerous metrics for impact. You can measure how many startups you've created. You can measure how many prizes you've received. I don't know. There's so many ways to measure impact, and so choose one. But you don't have to necessarily focus on a topic to get that.
Mhm.
That's focus on the output rather than the input, and I think that's I think a better strategy. Now, given that, it's not that I think what has happened in our lab is if there's also I realized this pretty early on that when you have too much focus in your lab, you have a lot of politics inside the lab because you have a lot of people who are working on very similar things and they're worried they're competing with each other because they're working on the very same topic. So if somebody has a great idea, they want to keep it a secret because if that secret leaks, then somebody else will move ahead because they're in the same area. If you have a diversity of topics, suddenly people collaborate more because they're not competing. Everybody has their own turf. Everybody's working on their own things. And suddenly they're much happier to collaborate. Hey, I know this skill. I'll help you. You're not competing with me. You're in a different area. Let's work together. So So in a strange way, you diversify, you get more collaborations. These are, again, not things that I planned ahead. I didn't think about this and designed it that way, but it turned out to be a much healthier dynamic. And again, if you happen to read that article, Financial Times, it talked about all these collaborations going on. In large parts because people are not very close in terms of what they're doing research in, and so they share the purpose, but they're not working, they're not competing directly. So that's another area. And last thing I'll say about this is that in academia we have a unique gift, a unique license, and that is we don't have a bottom line. We don't have to create profit. We don't have to work on something that is useful in the next quarter. We have a license to innovate. That's the gift. That's the deal that we get. We get public funds, and our mission is to innovate and have impact. That's if I have to summarize what public funded research is. That's our mission. And so I would say if a faculty isn't innovating or isn't doing so that gives you a license to do crazy things. Like industry cannot explore things that are too crazy. They cannot work on self-awareness because that's a philosophical thing, but it's not something that you need for next quarter. We have this incredible, unique license to do crazy long-term research that might be impactful. So we have to do that. This is our license. We are the only people on the planet that are a very small set of people that have been granted this gift, and we better take advantage of it to its fullest extent. And this is how you do it. I see it almost as a obligation to explore.
But I wonder if that thinking kind of permeates throughout all universities. Do you think that's a common philosophy, or do you think, I don't know. I know a number of universities in the UK and Europe, but I'm not entirely convinced they bring that approach. They may say that, and obviously that's going to attract students and so on, but I don't see them behaving that way.
I don't see it either. And this is something as department chair, I have to sometimes talk to junior faculty and say, don't listen to the old-fashioned advice about focusing and being an expert. The world is changing. You got to move fast. You got to think big. You have to have purpose. But not everybody does that. So people have diversity of approaches, and again, that's also part of academia. If you want to do something in a different way, go ahead and do it.
Mm-hmm. Yeah. One of the bars that must exist in your group, and obviously the FT article referenced this, and our additional research referenced this too. The bar for talent quality must be very high. And so you reference impact. It's important to have impact. So I'm a young PhD. I want to work in Hod Lipson's lab. And I have a proposal that demonstrates impact. Are you measuring me at all in terms of, my ability to realize that impact or to deliver on anything there? What is distinguishing, let's say, my application from, another 400 individuals who are also applying to the lab?
I think, yes, the world is changing and it's becoming easier in that sense. And so the way, again, different faculty look for different things, but when I am recruiting people, I look to see previous impact, prior impact. Okay, so I don't care. I really don't care about the grades. I don't even look at the grades. It's not that I look and I don't care. I don't look at it. I don't read reference letters. Don't believe in that either. I've written enough of them to know they don't mean much. The only thing I care about is what I call the portfolio. Okay, this is very similar to the way people are recruited in arts, in architecture, in fashion. Okay, I want to see the creativity in your past work. That's the only thing I care about. So when somebody applies and they're on the short list for whatever reason, and usually they're filtered by the university and we get some kind of short list of maybe 100, I Google them and I see what comes up. That's it. And if a portfolio comes up with cool stuff they've done in the past, then they're a good candidate. And if nothing comes up or something boring comes up, then it's not interesting. Now, the reason why I say it's easier than ever, because it doesn't matter where you are on the planet. You can create a website, you can create a portfolio, you can, especially in the area of robotics and engineering. In my area, it's very easy to get some components from online and build something interesting. It's very easy to write software. Anybody can do that. Baby can do it at this point. I mean, there's no excuses. So I'm not asking you to build a building. I'm asking you to build something interesting or to create some interesting software. And I think even people without academic background can do this. So that's what I also tell undergraduates. I tell them, my classes, you're not doing it for the grade. I'm going to give you a good grade. I'm going to give you all an A. Okay, I don't care if it makes you happy, but I can tell you the A doesn't matter. What matters is I'm going to give you opportunities to demonstrate your creativity, so that you can launch whatever it is you want to do next. And but you better think about what you're going to do that's going to demonstrate incredible creativity, so that you can put it on your website, on your portfolio. You can do it. And this is also answer the question. So what do we do when we have a AI that can do everything? Well, the bar is now higher. You take that AI and you do something that is so amazing that would be impossible to do last year, but you can demonstrate how you can use this AI to do amazing new things. Write a book, build something that would be impossible to design, but you've done it in one semester. Um, just reach for the sky. So I think it's actually easier for those who want.
Yeah. But there's no, good grades are no longer enough. It's not
Oh,
about
they're
that.
not, they're not enough. They're not even relevant.
Yeah. Yeah.
It's
Yeah.
only your
No,
portfolio.
it is. Yeah. That's very interesting. We're getting back
And
to
it's
that now.
harder to shake. It's harder to fake a portfolio. All right. I mean, you
is.
can fake grades.
Yeah.
It's just a letter. You can you can cheat on this exam and that, but to fake a project that you've done is very, very hard. To copy
And you can't
somebody
fake
else's
that.
project, yeah, it's too
And you
much.
can't fake that passion. You can't fake
You
that
can't fake the
passion
passion, and it's
and
also
the insight and wisdom and
too
learning.
much work to copy
No.
somebody else's project. It's very easy to copy somebody else's homework. So I think so I think people sometimes ask me, um, is all this AI making us dumber? And I think the answer is the opposite. The AI lifts the bar now, so that you really have to be creative in order to move forward. And I think that's the bar is higher, but you can also do more. So we're all just rising up.
Yeah.
It's not enough to be good in
Yeah.
math. You actually have to be super creative.
Your involvement at that point. So you create this deal with these researchers who come in and they get into your lab. And roughly how many researchers are admitted to your lab every year?
So I'd say we have, on average, I would say I admit one or two PhD students. These are the expensive, and a PhD is about 5 years. So that's like the full-time employee, if you think about it. There's maybe 2 dozen master students. Master students are self-funded, so it's a lot easier for me to do that, and maybe a dozen or two undergraduate students. And frankly, I'm very lax in admitting people into the lab, and they sort themselves out very quickly, because the projects are so open ended that if you're not self driven, you're not going to get very far. I don't have the bandwidth to babysit every student. So we'll meet sometimes when people in groups, sometimes, and some students I do such incredible work that they have to sort of earn my attention, and it's not deliberate. I didn't plan it this way, but there's just so many people. But if they do cool things, I get interested, and we develop a one-on-one relationship, and then it turns into a paper. But if somebody is just coming in to do homework and I'm going to tell them every week what they're going to do next, and they might fizzle out of it, and it just doesn't work. And I've had students like that, and I just don't renew their contract the next semester, so to speak. And they might get a good grade. I don't like to give people bad grades, but I'm just not going to take them on next semester, and they're
Yeah.
not going to have anything on their portfolio. So that's the bottom line.
So it's largely up to them to
It's
find
up
their
to
own
them. It's
way.
organic, but
Yeah.
I do say, look, I say here's some. I have a running list of ideas,
Mhm.
and I say, look, you don't have to do any of these, but here's things to spark your mind. And I this is a running list. Sometimes it's my head, but I try to put it on paper. I walk down the street and I say, "Oh wow, there's all these parents pushing their strollers uphill. Wouldn't it be nice if they could stand on a little platform and lean forward and have a electric stroller? Yeah, let me make that a project. Bam, it's a project. We're just launching one of those, possibly a startup to push strollers around town. So there's the ideas are plentiful, and again, I'm in a very privileged position where if I walk down the street and have an idea, bam, I turn it into a project. I have 3 people working on it the next day. It's an incredible. Again, no industry can do that. Nobody can create a project tomorrow and launch something and have so some of the projects are like that. They're very super. That's a super practical startup almost from day one. And some things are like very abstract. Like I say, wait a minute, you know what? I think I cracked self-awareness. I have this idea. It happens to me every other day. It doesn't mean much, but it's still. I have this idea. It happens when you work on when a robot has to do 2 things at the same time. Then it has to differentiate between itself and the task. I have some great, brilliant, brief insight, spark of insight. I create a project the next day, and there might be a student who bites into that. So some students want to create a startup. Some people want to study philosophical topics. Some people want to break a record in AI doing X, and so people come in with so many different things that turn them on in terms of research that you have to have a smorgasbord of things out there, and people come in and sometimes they say, I love this idea, but how about we do it this way? And then bam, it's off to the races. So it's you can see my style is unstructured. I just have a lot of options, a lot of people, good things happen, and that's it. It's almost like a numbers game. You just do enough of it, and good stuff happens.
But I think that's it. But I think it's from the way you're describing it, it's a numbers game, but it's also a real diversity game too. You need to have the breadth in there in terms of the domain, in terms of the different disciplines, in terms of the different skills and talent in the team and the different perspectives. You've got to have that diversity in there, not just to kind of ward off the competition and the political behavior that is unhelpful, but also to kind of, to help create new opportunities and new ideas and new thinking. So you have this home, this place where everyone feels comfortable engaging. And I'm guessing over time, if you've built it up and you have, it's going to result in a more chaotic, but potentially much more productive.
Right. There's a flywheel going on also here
Yeah.
that once you start engaging in many areas, I also go and speak in a lot of different conferences. The conferences are very, very diverse in the area. Like I said, could be with food one day, the next day could be automotive, and then another day it's going to be, some other topic. And when I'm exposed to all these different people, all these different challenges, I come back with all these different ideas. And so then I create even more things. And hey, did you know that there's this connection between, medical diagnostics and this area? And hey, we can do something with food printing, some crazy connections that spark even more projects. So I think there's a death spiral that happens if you're too focused. You become
Yeah.
very narrow in how you think. You now speak to a smaller and smaller group of people. You enter echo chambers where you're all thinking the same way. Now your projects are even narrower, and I can see this death spiral hit some faculty, and the research becomes until it either dies because they cannot get any more funding, or it continues, but their impact is negligible. And I also see that. I see senior faculty whose impact is dismal because they're so focused and so narrow and so rigid in the way they define what's interesting and what's not interesting, that they can't pick up, they can't get out of that spiral. So it's helpful to keep it out, keep it loose, not take yourself too seriously. I remember there's one advice that my postdoc advisor gave me, and I have to give a lot of credit to Jordan Pollack at Brandeis University for telling me this. He said, I had a big paper in Nature that kind of launched my career working in his lab, and he said, just because you had a big paper, don't think that all your papers have to be big. Don't forget about the small, insignificant things. And I remember him saying that as I left, and I keep working on small things. And you know what happens is that some of the small things end up being big, and some of the big things that I think are going to have a lot of impact have zero impact. So the truth is, even if I wanted to focus, I wouldn't know on what, because I can't tell what's going to have impact and what's not going to have impact. Yeah. So, I'm sort of, okay, I can't tell. Let's do it all, see what happens.
Yeah. But in the context of a lab like yours, just to play devil's advocate for a minute, is there a danger of kind of cannibalizing some of your other ideas? Or is that just kind of, natural Darwinian action and it's to be welcomed?
Yeah, it's welcomed. It's a free market, if you like. We attack the same idea different ways. I sometimes, there's even a little bit of competition on maybe on equipment, there's certainly competition on computing resources. I mean, there's a little bit of a Darwinian element. What's the biggest thing that people compete over in my lab? Space. Okay, so in Manhattan, space is a premium. We're on Broadway. You can't just build this, use 5 desks to build your thing and then walk away and come back a week later. If you come back a week later, half the parts of your system will be gone, and your thing will be pushed over to the left, and the new thing will have emerged next to it. It's a jungle, and that pressure, I think, keeps people also, there's people breathing down your neck in terms of space, equipment, compute, and I think lights the fire a little bit in a good way.
Yeah, it provides that sense of urgency to go in the way that New York can.
Yeah.
And New York does.
Exactly. So I think actually, moving from Cornell to Columbia, that maybe we'll talk about that later, but that's one of the immediate things that happens to you. At Cornell, you can think that you have time to do stuff, and you go to New York, you see you don't have any time to do stuff. Whatever you want to do is already been done, and maybe you can do it. There's a little bit more of that pressure, and you cannot escape it. You feel it every day, all the time.
I've got one more question related to this, and then I want to kind of go through and understand how you kind of arrived at this position in life with this, philosophy. My last question on this, a lot of the different things with which you're involved, with which your lab is involved, you've got, and I'm just reading from my list here, self-replicating machines, metabolizing machines was one of them, which I'm interested in hearing about. Food printing, jammy grippers, you mentioned robotic self-awareness, soft robotics, AI for science. A lot of these, they each have a slightly different time horizon in terms of realization. And so I get the point about impact. When you're, looking at someone that could, when you're evaluating a proposition that could have an impact in, let's say, 2 decades from now, versus something that could have an impact in, let's say, the next decade, in the next 5 years, does that make a difference? Is it more or less easy to evaluate or to deal with those things together? Or are you trying to, somehow group things in terms of time horizon?
I think you're trying to grasp at a methodology that I might have, which I don't. I don't have any methodology. I just have numbers. And
Yeah.
as long as it's, I don't want to. I want to have. So maybe if I have to think about it, if I really think hard, it's not a process I go to. But if I try to deconstruct myself, I think, look, if it's going to be long term, it has to have a huge impact. If it's going to be a short term, then it can have sort of lesser impact because it's immediate. There's less risk in it. The stroller is a short term thing. It's going to have impact, but it's not going to change the world. But self-aware machines or a new way to create food is a huge impact, and that can be a little bit more forgiving. You can go long term. So I think the diversity is probably a long tail spectrum or
Yeah.
something like that. But it's
Yeah.
not
Yeah.
a it's not a calculated thing. It's just
Yep.
it's
It's a
just
feel.
it's a feel.
It's a feel.
It's probably, I would say, VCs have a little bit of that gut feeling. They might say,
They
okay,
do.
this is high risk, high payoff. This is low risk but low payoff, and of course, everybody wants low risk, high payoff. Okay, but that's the doesn't exist. So there's the all those low hanging fruits are gone. So I think we're looking for those things, and there's a if you think about it, this economic Pareto front, and yeah, I am looking for something that's huge impact and
Mm.
immediate. Yeah, that would be
Mm.
great. That's hard to find.
Sure. Sure. Yeah. It's a bit of a unicorn. Tell me a little bit, just kind of walk us through the background, Hod, if you wouldn't mind, and kind of, help us understand, I guess, what are the kind of key events or key individuals you referenced, one earlier,
Yeah.
that have helped shape your thinking a little bit and you feel have helped you arrive at where you are today.
Oh, okay. So hard to go through that process. I would say academically, I grew up in a academic family. My father was a professor of physics. It probably shaped my thinking very much. He was engaged in physics, still is retired, but he thinks about it all day long. He did his PhD in Cambridge and was all about changing the world. He was involved in the race for liquefying helium and all these grand stuff that people are working on. And I got that, but he's also a hobby carpenter, and so it was I all day long saw him building things. It's a very much an experimentalist. I think that gave me uh, uh, a lot of sort of this initial fascination with science and with making things, and that permeates a lot of what I'm doing today. And I also, when people talk about their early life as a scientist, frequently they refer to, oh, I always wanted to take things apart and understand how they work. I never did that. I never wanted to take things apart. I always wanted to build things from scratch. And I would, Lego was my favorite toy, and I would be in my dad's shop building things. So building thing is my passion. I really want to, again, that recent Financial Times article is all about building things out of building blocks, and I think my Lego background is actually part of that idea that you can build a huge diversity of things from a small set of building blocks if you got the right building blocks. So I think so that's part of where it started. But then career meandered through lots of different paths. I was an engineer in the Israeli military for many years as in the Navy as a Navy officer, designing mundane things, not necessarily weapon systems. And as a designer, as any engineer will tell you, after doing 2, 3 designs of the same thing, you start thinking, there ought to be a better way to do this. I mean, there's no way that I'm going to spend my life designing things, door handles, brackets. I mean, this is shoot me now. Okay, there has to be a better way to go through. And I said, okay, instead of designing things, I'm going to design something that designs things for me, and design it once, and it will design everything. Instead of building things, I want to build something that builds things for me. I want to go one step meta on the design and build. And if you think about it, that's AI and robotics. That's digital manufacturing. And I remember that spark, I'm done doing things one by one. I want to solve it. And what I didn't realize.
When did that hit you, if you don't mind me asking? When did that when did you realize?
Sometime during my early engineering career, where I was just sitting there designing things and then just saying I'm not going to be able to do this for my entire life. There has to be something bigger. So some people go into management, which is one way to do it. We say, I'm not going to design things. I'm going to manage 100 people. They're going to design things. That's one. It seems to me like it doesn't scale either. You can only go so far. But if you can make an AI tool that designs things for you, not only you can design a million things a second, but you can solve things that we don't know how to design. Like you can design a solution to cancer. We can design a better battery that we can't design. So I didn't realize it at the time, but this is not just about doing more and making things faster, but about solving problems we don't know how to solve. It's the ultimate leverage, and I think that's what how it started for me. And since then, it's been a race from that. And different people, like my PhD advisor, Moshe Shpitalny, Shefi, as we used to call him. He was very open to that kind of thinking, and that gave me confidence. And he was also I learned from him the indispensable art of academic politics. Okay, this is how to talk to other faculty. He's a master, and I learned that from him. You cannot survive in academia if you don't understand that. And from Jordan Pollack at Brandeis, I also learned to be bold and think big. He sometimes said things that upset his academic colleagues, but had bigger impact than most faculty. So I learned that from him. I did a postdoc at MIT. Nam Su, department head in chemical engineering at MIT. He showed me, I remember this graph. He said, I remember one day I burst into his office with a bunch of ideas, and he showed me this. He drew on the blackboard. They still had blackboards back then. And he said, look, here's the chart of impact versus difficulty, or something like that. And he said, look, you can do very basic projects like E equals M, discover new physics, huge impact. Or you can do very super applied things like invent the new sliced bread, and also have a lot of impact. But there's a ton of things, but both of these are very difficult. The easy part is to do things that are in the middle. They have a little bit of impact, and they're not very unique. That's where everybody goes. Don't go there. You go to one of these two extremes. And I remember he showed that, and I walked out because all of my projects that I proposed were in the middle. They were kind of interesting, cool, a little bit of impact, not going to change the world, ton of things to do, but not going to have much impact. He said, "Don't. That's where everybody ends up. Don't go there." So I went out of his office with all my ideas still in my pocket, and I thought, okay, I'm going to I'm going to do one of those extremes. So everybody gives you something, and Jordan told me, don't be afraid to do small projects. My dad told me, never decline a speaking invitation, no matter how small, because that's how you build a community. I remember that. And everybody gives you a little piece.
Yeah. So for your MIT professor's point, what is the big, what is that contribution or that project of impact that you feel best represents you? Or, to your point earlier, is it almost a meta thing and you've created a group of people or a lab that are now having all of those impacts?
Well, okay, so I think that's if I tell you my biggest impact that I've educated people that have had impact, that's a little bit of a cop out, I think.
Yep.
I'm gonna revert
Yep.
to that if I have
Yep.
nothing else. All right.
Yep. Yeah.
Okay,
Yeah.
because I'm gonna say, okay, they did it. But if I
Yep.
have to list my own, first of all, it's not over yet. So I don't want to say, well, my
Of
biggest
course not.
impact was no. Okay, I'm still going, and I have some ideas, but I think it's changed over the years. All right. So I started. I thought digital manufacturing, 3D printing, was the biggest impact in the beginning. I developed 3D printing. When it was not cool, it became cool. People think it's passe, but it's actually growing 25% per year. It's the new way of making things. So that was a big impact. I created a field called bioprinting, printing with live cells. When I started, people said it's crazy, it never worked. I couldn't get funding. Then created a company. Now there's a field of bioprinting. There's journals. There's conferences. This is the way we're going to create replacement organs. That's going to be huge impact. And I think it's going to play out. Food printing hasn't happened yet. I've been at it for 20 years. People are not buying into it. I'm telling you, it is going to be. Eventually, uh, you know, robotics and food are going to come together. There's no doubt food is a big part of our life. Manufacturing and software is a big part of our life. Eventually going to come together. We'll have automation in our kitchen. Hasn't happened yet. I know it's going to happen. Self-awareness is my long-term biggest sort of thing that I've been at for a long time. It was a joke in the beginning. It was not even a joke. It was a taboo in the beginning. I couldn't tell people I'm interested in this question of can machines be self-aware? I mean, it's more of an oxymoron than creative machines. The idea that a machine can think about itself. I mean, where do you even start thinking about something like that? But now it's actually not so crazy, and it's going to. And before you know it, we'll start thinking about sort of machine psychology and things like that. So this is all going to happen. I feel that's a big impact. I mean, there's a bunch of things. Automating science was another one. We were almost the first to create a machine that can rediscover physics laws from observation. We've done some work since. And again, now it's a whole community. And so oddly, once a whole community flocks in, I leave. I know it becomes too crowded. It's frustrating because you see a lot of people reinventing things you invented in the past, and you're saying, but and then I become this old guy who say, I've already done this before. I don't want to be that person, so I just kind of move on and do something else, and I'm happy just to see some citations come out of it.
Yeah. I've got one last question for you. In one of our very early conversations, you mentioned, we were talking about AI right now, and what we might see in the 2030s as it relates to robotics. And so, if we think AI, and I think you said something along the lines of, if you think AI is big right now in the 2020s, wait until the 2030s and robotics. Can you expand a little bit more on that?
Yeah. Most of our world is physical. Most of our things we do all day long is we bump into the physical world. We move things around. We do stuff. And by large, this has remained analog. We are not competing with machines in the physical world. And when that happens, our lives are going to change so dramatically that it's hard to imagine right now. And what I'm seeing is that the same techniques that are being used to create virtual intelligence, machines, AI, that agentic AI, if you like, AI that can do things in the virtual world, the very same technology applies to robotics. It just has to work on a on both it's harder because it involves more channels that have to move at the same time. It's not just text to text. It's not just translation or generate a sequence of proteins. It's actually move 15, 20, 1,000 muscles at the same time. Mistakes are expensive in the real world. Time is slow. Real time is slow. You can't accelerate the real world, and there's energy limitations. So the real world is difficult, but the same techniques work. And I can see behind the scenes the amount of effort to scale those techniques that worked well for virtual intelligence and make them work in the physical intelligence. The same techniques work. We just need to pump in more compute, and this is part of why you're seeing all this buildup of infrastructure of computers and energy to support that. But it's clear to me all the curves show that this will be solved in the 2030s, early 2030s, and when that happens, all bets are off. It's all bets are off because so much of our world is physical, so much of our supply chain, our livelihood, everything is physical, and it's not going to happen overnight. Knowing how to use your hands in construction is different than being a dentist. It's different than folding laundry. There's a huge diversity of ways in which we're physical. So it's going to take time to unfold, but I see it as I can see in your eyes that you are thinking it's bad, but it's actually or terrifying. But I think it's actually the again from my point of view, the leverage that we'll have as a species is enormous. We will be able to build new things that would have taken us a century. We can do it in a week. I mean, we will be able to build things to solve physical problems that are ailing us at an incredible rate, and we'll have no excuses. So I can't wait for that to happen. But what we need is the self-confidence to do that. And I find myself the most important thing that I teach, if you like, as a professor at this point is self-confidence. I say, all these are happening. All these tools are going to be at your disposal. Students that graduate now, you're going to live your entire career, your next 50 years, if not more. You're going to be in a world where you just say what you want, a machine will do it. So you better have the confidence to make the right choices. If you cower and wait for somebody else to tell you, it's going to be game over. In fact, the machines will decide for you. So you better wake up, think about what you want, and be able to articulate that with confidence, because you'll have the tools to make that happen. So this is true for everybody, but not everybody's ready for it. So I think we have to get ready.
And I don't think we could have designed a more perfect ending to this show. That's perfect. Wow. That's exciting. That's hugely exciting. Hod, thank you so much for joining me today.
Thank you.
This has been great. Really, this has been fascinating to listen to all of this. So much to pick through here. So I'm so grateful. Thank you again.
Thank you, Chris.
You've been listening to the Lab to Market Leadership Podcast, brought to you by Deep Tech Leaders. This podcast has been produced by Bauhaus. You can find out more about us on LinkedIn, Spotify, Apple, or wherever you get your podcasts.